online as well. Excellent. So it's a great pleasure to invite Ben Goldacre, who's from the Bennett Institute in Oxford, where most of you, nearly all of you here, will know of his work. And it's great to get Ben here so we can see what the sort of building institution which respects and loves because it was seeing that humiliatingly crass building that you were in. It was just so shocking. But,
Thank you, and thanks for having me. Sorry if you slow. I think the taxi driver took a long route, so we've made about 10 excuses for a bit longer. Well, thank you for having me, and I love Bristol so much and wish I lived here. Does anyone here, does anybody know the Moonflowers? 80s? Oh, wow, nice. And anyway,
it's Beak.
Beak are obviously great. Do you know the glitzy bag hacks? They're like, if you ask ChatGPT for the prototypical Bristol bag, they're in pink fun fur and playing Gypsy Star. Anyway, thank you for having me. I'm going to talk about OpenSAFELY, which is the electronic health records research platform that we built, but also talk more broadly about what's changing in epi and electronic health records research and the slightly different working methods that you have to develop to take advantage of that. So I run a thing called the Bennett Institute in Oxford, and we are slightly peculiar in an academic setting. First of all, we're peculiar in terms of our interests. We like taking large data sets and turning them into traditional academic research papers in academic journals, but we're also really interested in health services research, and not even stuff that's fancy health services research, just simple descriptive statistics, crosstabs, graphs for trends and variation, for service monitoring and improvement in the NHS. And actually, it's kind of weird that that used to be a normal thing that academics would do in the world of public health. You'd see infection audits in the Lancet in the 80s and 90s. And then gradually it has become more and more kind of relegated to the sidelines. And then also public health has drifted off into local authorities, which had sensible things behind it, but ultimately has meant that the world of people with a bit of clinical knowledge or a bit of epi knowledge or a bit of both working in the health service to do practical data analysis for service monitoring and improvement has kind of dwindled, which I think is a real shame. That's not what I'll be talking about today. Secondly, we're a bit odd in that we don't just build outputs like dashboards and tables and reports ourselves. We build tools and services to make data faster and easier for everyone to work with. And we don't just use those internally, we share those to the whole community. So we build things like openprescribing.net, which I highly recommend using. You can go to it and you can type in the name of your GP practice, and you can see off a data set of billions and billions of rows, exactly what your GP is prescribing month by month. You can see what they're an outlier on compared to their peers. You can see which treatment recommendations they are fast or slow to respond to, or which they have completely neglected to engage with. And we also build things like OpenSAFELY, which I'll talk about today, which is this electronic health records research platform that gives access to the whole nation's records. Now, to do things like that, to take large data sets and move beyond just writing linear scripts in Stata and R and Python into reusable, repurposable tools and services that everyone can use, you need a different kind of person. So because we don't just do research, we don't just hire researchers. There's about 65 of us now. There's probably going to be about 80 or 85 of us after our current round of hiring, after which we stop. It's weird. And maybe a third to a half of us are some software engineers, one way or another. Now, these are not the stats person in your team who's weirdly good at Python and R. Those people are great. They've got really strong domain knowledge around stats and epi, and they know how to push and drive R and Stata. They might know how to make a function or write something that's documented and generalizable. But what they're not is a software engineer who's worked for maybe 5, 10, 20, 30 years troubleshooting and thinking about how to make generalizable frameworks. So we hire people who used to work on owning a bit of the Ubuntu open source operating system, or running the entire database backend of not a research project, but a clothes retail outfit. They know nothing about research. Our researchers initially don't know very much about how to work with things like GitHub or what unit testing or functions are. But over time, and in an increasingly structured way, we get people pooling skills and knowledge. So we have software developers who know what electronic health records are, what they look like, what they're used for, what the pitfalls are, what the opportunities are. They know what observational epi is. They know what matching is for a case control study. They know what clinical trials are and what NHS England does with data and what doctors are interested in seeing with data. And similarly, we have researchers who don't become software developers, but they start to learn what a GitHub are. That's a bad joke, a diagnostic joke for 3 people who laugh are my target audience. So they learn what GitHub is, they learn what Python is, but also they learn about ways of working, pull requests, code review. And the whole shtick, the whole purpose of all of this is to fuse best practice from these 2 different communities. Because if you're going to write code to manipulate data, I use manipulate in the nice meaning of the word rather than the contemporary meaning. If you're going to write code to manipulate data, it makes sense to have people who understand data and people who understand code, who've written code for their whole lives as a profession. So that's the context in which we built OpenSAFELY. This is an hour-long slot, is that right? And you would like me to...
But they're going to kick us out in about 50 minutes.
50. Got the ring
It's not quite. Even quicker than you normally talk.
Well, so, I mean, I suppose the question is, what would you... should I leave 15 minutes for questions? All right. And what do you want? Do you want to hear about OpenSAFELY and how we built it and why, or technical details about what it is and what it looks like, or electronic health records analysis, or...
The more general.
Okay, fine. All right. Is it being recorded as well?
Yeah.
Are you going to put it on the internet?
If you'd like, but if not if you want to, not.
No. Okay, I'll mostly be very generous and polite. All right, so March 2020, everything suddenly began to look a bit worrying and bleak. And of course, the thing about March 2020 was, a bit like in 1939, they didn't know it was the 1939 to 1945 war. So it was a genuinely frightening time. Also an exciting time. It doesn't make you a psychopath to say it's exciting and thrilling to live through something horrible. I was in a meeting in NHS England on about March the 10th, and it was chaotic. And it was chaotic in a frightening way. People were working hard. It wasn't that anyone was at fault. But I came out of that meeting thinking a lot of people are going to have to do a lot of good, hard work spontaneously, and we could be in trouble. And the first thing that I thought was, we're not going to be able to do analysis on NHS electronic health records data in any sense quickly or accurately or at the right scale with the current data flows. So things like CPRD, for example, where they extract a bunch of data on patients where the GPs are happy or inattentive to the privacy model, which is extract the data, take names and addresses off and just send it to lots of different places around the world. But setting aside the privacy and efficiency challenges of that model, it's also incredibly slow-flowing data. And it's the same for all of the GP data extraction and dissemination projects. Wave 1 and indeed Wave 2 would have come and gone, and in fact did come and go before a single case would have appeared in any of those data sets. So you had to be quick. You also needed data that was bigger than what's gone before, because it's one thing to say, well, you know, how many black and brown people are getting COVID compared to white people, because there are a lot of black and brown and white people in the country. But if you want to start understanding risks in smaller and smaller groups, then you're segmenting the population down into finer and finer subcategories. So you go, all right, everybody's excited about chloroquine. I mean, now only fruitcakes are excited about chloroquine, but at the time, it was a legitimate field of inquiry. Lots of people are excited about chloroquine, so we ran to open prescribing. We took a look. There's about 100,000 people, it looks like, getting chloroquine every day as a matter of routine GP care for things that they've got chronically in the community. And so maybe you want to look at COVID admission, infection, death rates in people who've had chloroquine versus people who haven't. But then you start looking at the numbers of deaths, and although they're big and they're frightening, if you cut them down so that you're comparing the deaths in 100,000 people compared to the remaining 58 million of the population, the number of deaths in that 100,000 is going to be absolutely tiny anyway. And then if you cut that down to a 10% sample of the data, it's going to get you nowhere. So we knew that we needed data that was, first of all, bigger than ever before, the actual national scale data that people have talked about forever, but never delivered on. We knew that we needed data that would flow in as fast as possible near real time, rather than a 1-year delay while people do things like extraction, what they call data cleaning, although not throwing shade at any individual project. But if anybody ever tells me they've cleaned the data, I want to know precisely what they've done to it. And if they can't tell me, then I don't want that data cleaning to have been done, please. One person's data cleaning is another person's catastrophic destruction and error. So we knew we needed faster, larger data sets. And so we set about building OpenSAFELY. Now, I'll tell you quickly what we've built and the kinds of things that have been done with it, including by people who are here. But then I'll talk mostly about how it works and how we built it and what it does that's slightly different to other platforms. If you press buttons, does that usually make slides advance? That seems like the generic. Oh, yes. Okay, so OpenSAFELY now is 58 million patients' records. We're supporting 181 projects from 31 different organisations, over 100 completed outputs. It was about 42 days from first shovel to first output. So our paper that went on to be a Nature paper, we got the preprint out, I think, in April 2020. And the total spend to date is about 10 million, with lots more announced just very recently. When I say different organisations, I mean very different organisations. So mostly universities, but also increasingly non-university users. So NHS England, UXA, NHS, but also third sector players like Prescript, who do a sort of community interest company doing variation in care for prescribing. And historically, our legal basis has been COVID only, but COVID covers a vast number of different research types. So first of all, who gets COVID? Different ethnic groups have different risks. The different disease subgroups have different risks. Does household transmission play a role? So by building a household pseudo-identifier, we were able to do the largest study ever conducted on whether an older person living with a primary school-aged child is at increased risk from that primary school-aged child bringing COVID home, or decreased risk, because as anybody who's had children will know, they bring home a lot of viruses. So are you so overexposed to different coronaviruses over your life that you have a kind of residual resistance to COVID-19? Then lots of stuff on treatments. So do treatments work? What are the benefits? What are the side effects? But also monitoring who gets them. And the same with vaccines. Do vaccines work? And lots of stuff by people like Venetia here, but also who gets them and do they have adverse effects? And monitoring who gets them is really critical because, for example, you might want to know, well, first of all, are we only giving it to people who are in the right risk categories? But then you might want to go within those risk categories. Are we missing the people who are higher risk, especially in the early days when you had to get the Pfizer vaccine through cold chain? Were people who had learning disabilities less likely to get the vaccine? Answer yes. Were patients with pre-existing cardiovascular or oncological problems less likely to get the vaccine because they were also housebound? Answer reassuringly no. So then, consequences of COVID. What happens afterwards in terms of health service utilisation, hospital admission, other diseases, clots, who gets long COVID? And then lastly, how does NHS activity change over time? How is the activity in the health service perturbed and disturbed, and how does it recover? So these are just some of the outputs that you can see on opensafely.org/research. This is our first big paper during the pandemic. Somebody reposted this with a picture of the Death Star behind it and said it was the most frightening image in Star Wars. And it really is, right? And I think people don't experience the sort of the right degree of visceral terror from data. What's the line from, what's his name? Mortality tables are death with the tears wiped away. You're better than ChatGPT. That was, who was it? LSHTM, Aubrey. No. Anyway. So that one. And then lots of things. This is 58 million people who's being coded as having long COVID. This is household transmission. This is 58 million people who's being listed as COVID vaccine declined. And this is the kind of full galaxy of vaccines work. So Will Hume from our group, Elsie Horn from here, and Tom Palmer from here, and a galaxy of stars, and Elsie Horn and everybody. And then COVID treatments, do they work? Who's getting them? Lots of coverage in the media. The thing that I found actually really exciting was being able to monitor in near real-time health service activity. This, in particular, when we first got this off the machine, it was about here, and I genuinely felt a little bit tearful. So, you know, first of all, there's that thing where you're the only person who knows the answer. Like, you've typed the commands and you do Control-D if it's Stata in the olden days, and you put some coal in the little hole around the back of the laptop, and it chunters away, and then it says, oh, sadly, your model didn't converge because these things are co-linear, and you get cross and sad, and then you come out and you do it again, and then the answer comes. And there's this period of time where you go, I'm literally the only person who knows the answer to this. And when this came off, it was about there. And what this shows you is people stopped doing cholesterol tests, which are non-urgent in primary care, and they carried on doing INR blood clot tests for people on warfarin, which is non-deferrable, got to carry on doing that. And the reason this is genuinely moving, I think, is this is 68,000 GPs across the country with no central edict or instruction or control, all of them sensibly adapting their clinical practice to the context of a global health emergency. They basically all stopped doing cholesterol tests. I mean, I kind of wish they hadn't resumed them quite as much as they do. That's my question. They all stopped doing cholesterol tests. They all pretty much carried on doing INR. And I think that's an amazing thing. And when we were hunkered down in March, April 2020, and we first saw that, it was one of those moments where you just go humanity, well done. Look at you adapting to your circumstances rationally. Less of that later. So. All right, so the data that's successful through OpenSAFELY, it's the full coded GP records of the whole country, so no free text, we don't want free text, although we've got ideas about how to do free text well, but full coded GP records, for those who don't know, is everything that your doctor chooses to record and everything that is automatically recorded as part of the natural operation of the electronic health record system. So your doctor will put in a diagnostic code for you, probably. They probably won't put in any symptom codes because it's just a lot of time and effort and it doesn't really help anyone. Every blood test and its result, well, that comes because the blood test gets sent off through an electronic system and then comes back through an electronic system. Every referral, every prescription, because the prescription is probably going to be issued electronically. So by understanding how data is collected and how humans use the machine in front of them, you can start to learn a lot more about the sources of completeness, of error, of confounding, and of bias in the electronic health records that some people might otherwise just take for granted as if it was sort of the truth, as if it was God's giant SQL database in the sky, telling you what the diagnoses and the symptoms and the treatments are. It's not that. It's what a machine did when it was being operated by people after being designed by people. Linked onto that, we've got, I sort of drift into the psychedelic because I'm in Bristol. That's not something I would say. So HES and SAS hospital data. So that's one row for every hospital admission, episodes and spells. Which way round do they go? Your life depends on it. Haha, not really. Every outpatient appointment, every A&E attendance, and then a bring your own data service where we brought in bits of UK renal registry, bits of COVID surveys, brought in a randomised trial from some people in Bristol. Anyone here work on that? You see, we helped you do the largest randomised trial ever conducted in British primary care. You couldn't even be bothered. A household pseudonym and lots more, and then ONS, death and causing death. I must say, by the way, in terms of kind of strategic thinking on data infrastructure, right, the place you start is not with our adorably detailed but adorably chaotic hospital electronic health record systems, where about a dozen trusts in the country still have no electronic health record system, and about the same number have more than 12 electronic health record systems working at the same time, because some guy who runs the paediatric department wrote his own electronic health record system on the BBC Master, not the Model B, the Master, with the disk drive and everything in the 1980s, and now they still use that, right? There's a lot of that. If you want to go far and fast, you start with the things that have got biggest bang for the buck, and that's got to be GP data, HES, and death. There is nothing in life more than GP, HES, and death. The intentionality of your existence on the planet. So, GP data, why is it amazing? First of all, it's got breadth and it's got depth. So breadth, one record for every citizen. Depth, lots of information about every healthcare transaction in primary care and lots of traces of your secondary care things too. Because of that breadth and depth, you can use huge amounts of it to do research on everything you could possibly think of: causes of disease, prevention, treatment benefits, risks, uptake, and costs. You can also do tons on improving healthcare. So you can look at who gets which treatments, where, which patients are falling behind, which institutions or types of institution are falling behind, adopting new evidence-based treatments or deprecating old, no longer preferred treatments. And so you can understand the reasons for variation, get a window into the pathology of the medical profession as much as the treatments. But because of these huge, because of the breadth and the depth, that also brings problems, right? This is the nature of life. It's like personality. The same core personality variables make you effective, but also tiresome, right? The same with data. The same breadth and depth of the records that make them useful also make them hazardous. So first of all, there are privacy challenges. The same records that generate insights inherently also contain the most confidential medical records and secrets of the whole population. And you can't just say, we'll take names and addresses off, because it's not that easy. So the standard illustration of this in security engineering textbooks, like Ross Anderson's classic Security Engineering by Wiley, genuinely cannot recommend highly enough. It's 800 pages long. He died tragically recently. If you like reading other people's textbooks in other fields, Mankiw for economics is very good. Security Engineering by Ross Anderson should be a series of pop science classics. It starts with all the research on what happens if people make you change your password once a week. Can't see you write it on a post-it note next to your computer. And then goes through all the horrible maths of Janet and Bob or whoever they are, and somebody's listening in, all the encryption maths, and then gets into systems engineering. And the section on people using electronic health records and administrative data has a whole series of examples of why taking names and addresses off is not a good way of protecting privacy. So, for example, Tony Blair, remember him? He had an abnormal heart rhythm reset in October 2002 and September 2003. If you know only that a 48-year-old man, resident in London at those moments, had events of that class in HES, I can show you the SQL query that you would write if you've got a DVD containing HES. Hands up who's got a DVD containing HES somewhere. If none of you put your hand up, that's because you did have one from LSHTM Digital, and you can picture where it was on the shelf, but it's sort of, where did it go when we moved to the window building? Anyway, you run a SQL query, you can find the only person in the country who has those events at those moments with that demographic characteristics, even with only very broad brush information about Tony Blair, and then you can find all of the other events associated with that pseudonym. So it's very, very easy to re-identify people if you take names and addresses off. That's why it is incredibly dangerous to just say we're going to take names and addresses off and then give lots of people access to this data. By the way, it was fine in the olden days. So I am the second generation of my family to be an electronic health records epidemiologist. And when my dad started doing this in the 1970s and 1980s, it was all on great big tapes, right? I used to ask to go and see the computer, the typewriters that type back at you. So it was SPSS 0.3, you go clack, 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 you wait, and then a daisy wheel printer produces the results tables, right? In that era, only about 12 people had access to things like HIPE, the predecessor of HES, hospital records that cover the whole country. And it is okay to trust 12 people to do the right thing, because you always have to trust some people to do the right thing. What it doesn't do, that approach, is generalize to an era in which you want to give tens of thousands of people access to whole population records that are much richer than anything before. To do that, you've got to do something better on privacy. So that's privacy. We got the ring till 11 tonight. Transparency is a related but different challenge, which is that people, professions, campaigners, patients, they want to know what's been done with their medical records, right? It's not just about whether you're doing the right thing or the wrong thing. People just want to know what you have done. And also, if you've had permission to do a set of things, they want to be assured that they can see what you've done to make sure that what you've done aligns with the things that you have said that you're going to do. And there are very good reasons, some of them in the public domain, some of them not, to have concerns about whether people only do the things that they are allowed to when they get access to data. You may, for example, know people who go, Oh, I was thinking about doing this thing in CPRD, but I did a quick check on Sally's copy and it looks like there aren't enough patients on that third line diabetes drug. That feels okay, but it is a breach of the permissions under which you've got CPRD. But don't worry, nobody knows that Sally did that because it's on Sally's laptop. In fact, it's probably on many of Sally's laptops as she throws the old ones away, and who knows where those hard drives appear later. Hands up who signed a data destruction certificate for a CPRD or HES. And what about the backups of the university thing? I mean, all of the paperwork and the policies around this stuff are, frankly, for the most part, fictions. Did you go and find the backup tapes? Do you know where the backups even go? Do you have a relationship with the person who does the backups where you can say, hi, just this folder? Can you delete just that? But from literally every copy you've got of this forever going back in time to about 2002. Has anybody ever tried having that conversation with Google Cloud Platform or any of the other places that have got your copy of CPRD and HES? It's amazing, isn't it? Anyway, you're not the wrong uns. You need people to make platforms and services that make it easy to do the right thing. So the last challenge is usability, right? So this is not a problem of platforms, this is a problem of the data, right? 58 million patients, detailed electronic health records. It's hard to work with, it's huge. It presents challenges around data management and data interpretation because of the sources of missingness and error and bias and confounding in the data. You need to understand what the data is, where it comes from, how to do DQ checks on it in a systematic and structured and reproducible way. But also, you've just got to do the basic job of managing it in the first place. And it's really big and really slow, right? Hands up who's got a tune that they play at the end of a stated do file very loudly so that you know when it's right. You set these things off and they run for hours, right? And that's with your little cut of data. 58 million patient records, right? These are big, difficult data sets to work with. So, let me run through quickly how we built OpenSAFELY and how we try to manage some of these challenges. So OpenSAFELY is unusual in two principal ways. First of all, the things that we did to manage trust, and secondly, the things that we did to manage efficiency of working with this data at scale. So trust, privacy, and transparency. First up, we don't extract the data and then put it on my machine or make me the data controller. I've always found it rather peculiar that some random prof at some random university is the data controller for millions of patients' records. It's the person in charge of ALSPAC here. I mean, it's okay, but it's odd that it tends to be people or institutions without statutory obligations and responsibilities to ministers and parliament and the electorate. I didn't feel comfortable with that. So from the very outset, just on a policy level, the data controller for the OpenSAFELY platform as a whole has always been NHS England, and we were insistent on that. And the data controller for the GP practice level records, the most detailed records, the one row for every event, that remains the GP practice for the source data, because we build our tools inside the data center that contains those data. So that is the second big move, which is the records don't move. The GP electronic health records stay put. They stay on the computer that the GP practice has chosen to own their electronic health record systems. So some of them buy TPP, some of them buy EMIS. In the olden days, some of them bought Microtest, but now they've gone bust. In the future, some of them might buy not Segedin, they've gone bust, the other one. Anyway, so we don't extract data out of there. We build our query and analysis tools on top of the local copy of the data. Next up, and this is the really clever and tricky bit, we don't give researchers a login to a remote desktop where you just log in and you go, okay, here we go, SQL window, the entire nation's GP records. Select star from, look up my mum's new boyfriend, right? You don't get that kind of permissive access to the raw underlying health records. Instead, the OpenSAFELY platform gives you randomly generated dummy data, which is just good enough for you to write and test your code. It'll tell you that you've not put a comma in the right place, so that you haven't closed some brackets. It won't be able to tell you when you test it that your model didn't converge because these two variables are collinear, because it doesn't know anything about the real data. But that's okay, because when your data is tested as capable of running, you press a button, your code gets wrapped up and sent off into the electronic health record system that the GPs have chosen. And there it runs against the real data, and you get back your tables and your graphs, of course, because that's where the outputs you want to see, and you get back your log files. And your log files, just like when you're working normally, will say, this model didn't converge because those two things are collinear, or this bit of data reshaping didn't work because you've said everything under 3 should be A, everything over 3 should be B, but one of the values is B already. So what do you want me to do with that? So you get the log files for that in the same way that you would when you were working normally. Let me show you very quickly how that works. So you go and see your doctor. Every time they make a diagnosis, a diagnostic code gets entered. Every time they give you a treatment code gets entered. It's just an extra row. Your entire electronic health record is basically a spreadsheet containing a load of events. The entire electronic health records archive of the nation is basically a two-way table. It's only 7 columns wide. There's pseudonym, date, time, place, event code, and an associated variable. So the event code might be had a systolic blood pressure taken, and the variable is 40. It's just has to be hundreds of billions of rows long, that's all. So you go see your doctor, rows get added, usually Venetia or similar, they sit down and they interact with this directly. That is literally Venetia, by the way. We can thank Venetia on Venetia for this video. But instead of giving Venetia the real, we did get your glasses, absolutely perfect. Instead of giving Venetia the real data, the OpenSAFELY machine appears, gives Venetia randomly generated fake patient data, which she then uses to write her code. Then you press a button. It looks like this when you log in. Does it still look like that? Yeah. So you log in, you go, hi, okay, I want this GitHub repository that contains my code, which I've tested against randomly generated dummy data. I want you to run it against either of these backends. And then the machine takes it off, runs it against the real records, and comes back with your graphs and your tables and your logs. And all of the normal frustrations still apply. There are no, it's not like it eradicates magically lots of other things. It still goes, this didn't work. You see it in the log files, you do round trips, and you fix it. The last thing that we did for trust is total code level transparency. So I don't think I can access the internet from this machine without making the people on Zoom sad. Are there really people on Zoom?
Yeah. 60 on.
I mean, today rather than as a general principle. Okay, so if you go to jobs.opensafely.org, you will see this, and this is a live real-time log of precisely what is running in the platform. So look, there you go, Bristol. Might as well while we're here. All right, so this is a screenshot from a few months ago, I think, probably for a slide deck. So you can see live as it runs, you can see the organisation, the person, the project, when it started. If it's still running, it looks like that. And if you click through on those, you click through to more information about the job. If you click through from there, if you click on repo, you get sent to the actual code repository that contains the actual code. And there you can see literally the code that is being run against 58 million patients' records. So that is complete transparency, philosophically complete. I mean, as in, there is literally no more that you could possibly know about this is all that is happening to the patient records, and you can see it live and in real time. And so this is just some of the repositories that have been produced by our users, coming up for 300 repositories of code from our users. So, interesting thing, when you go to this much effort, this is a little bit harder than just going, okay, select star, replace NHS ID with a pseudonym, which you can literally do in Excel. You know, Excel actually supports SHA-256 encryption. It's not, and right, this is a bit harder than just extracting all the data and emailing it to your friends, right? But when you do it, all the people who previously said no to everything that anyone ever tried to do with electronic health records, RCGP, BMA, Med Confidential. RCGP and BMA didn't say no to everything, but they said no to stupid things like care.data and the successor to care.data. But when you go to this effort, the people who previously said no say, actually, yeah, this is great. So RCGP, BMA, Joint GPIT Committee, Med Confidential have all written formally on the record to Secretary of State twice, saying not only will we tolerate OpenSAFELY as a means of accessing whole population GP data, we actively encourage you to use it more. Most trusted in citizens' juries and so on. Okay, so that's trust. Very quickly, 5 minutes. Efficiency. So electronic health records, hard to work with. So we standardise the code that people use to prepare it. And that means that everybody can see and reuse everybody else's code. It means they can understand it, reuse it, adapt it, and improve it. And it also means that we can run the same code against multiple different data centres that contain the code. So GP electronic health records in TPP are stored on a box in a room in Leeds on Microsoft SQL Server, can't remember which version. The electronic health records of EMIS patients are in the cloud, in AWS, in an ever-changing parade of things implemented on top of AWS buckets. Every time that either of those changes, we change our translators. So you write Urkel code to prepare your data. The point of that is, first of all, to make it legible, composable, and so on, and I'll try and tell you something about that in a moment. The other main point of it is that the same code can run in many different places. So completely different databases, completely different ways of interrogating them in those different environments. But historically, you'd write code that was tailored to one database. With Urkel, it's the intermediate layer between the code that you write for data preparation and the places where it moves. So it means you're future-proofed against vendor lock-in. You can do federated analytics and more. Next up, efficiency comes from having engineers and researchers working side by side, pooling skills and knowledge and best practice. Next up, efficiency comes from user support and documentation. So there's about 100,000 words, a comprehensive technical user manual. If you want to know how to prepare a particular variable, you don't go and find Sally down the road who did it for her PhD, but that was ages ago and things have probably changed. But she was quite good and she's got some things that you might be able to copy and paste, but you'll have to change some of the variable names and also update the code lists. Instead of that, you have just a user manual that you can navigate. And because you start working on dummy data, and because you then carry on working on dummy data until you've got your project approved and can run your code against real data, if you want to start playing with OpenSAFELY, you can do it today. Probably take you about an afternoon if you know how to write a line of Python. We've set it all up really quite nicely now with code spaces. Do you believe that? Yeah. So code spaces means instead of having a place where you type on your computer, you have a place where you type in the browser, and it's all set up automatically. So it connects to your GitHub account, connects to the OpenSAFELY framework. When you write your Urkel code, it auto completes it. It even formats the different types of thing in the code with different colors. It's a beautiful thing, right? And you could start doing this before school pickup this afternoon, if you clear the afternoon. And then lastly, a modular approach. So as far as possible, we build things in a way where, you know, it's not perfect, because perfect is hard, but it's pretty good. Things like for users, the actions framework. So somebody wanted to do case control studies and matching over and over again. We took their code that was copied and pasted in Stata for 10 years in Liam Smith's group and turned it into an action with documentation that everybody can invoke with a single command. People from Bristol have made actions, haven't they? And sometimes you do that for something fancy, and sometimes you do it for something really simple and trivial, because, you know, great leaps are made from multiple simple, trivial things. So overall, the data's locked down and everything else is radically open. So next, we're doing cautious expansion into non-COVID work. I'm overdue to finally review that last bit of documentation that was sent to us last night on that. Some interesting new features for users, but I won't tell you about those today because we know our actual users and we talk to them and observe them. And also the rule of good cultural hygiene when building tools is show the thing. Don't show people a big PowerPoint slide deck of the plans of things you're just about to make. If you ever see anyone doing that, you should smile very politely. Take the check that you were halfway through writing, just gradually pop it into the bin. Any bin is fine, and back away, right? You need to show the thing when you're building things. You have value in the first month. And then lastly, non-health data. So we just got a big slug of cash from philanthropist and from Duffield Trust to start building our tools on top of education data, because education data conforms to a very similar stereotype of electronic health records data. It's basically all transaction data, one row per event, a place, a person, a date, time, an event identifier, and an associated variable. And so that's what you see in lots of things like National Pupil Database, internal education management things, tax databases, and so on. So I can stop there, or I can show you a bit of Urkel. What do you prefer? This is choose your own adventure. Wave your hands if you want to see some actual code for electronic health record query language. Wave your hands if you want me to shut up. And more interesting questions from you. That's a minority for shut up. Okay, I'll show you some local very, very quickly. All right, so working with electronic health records data, it's really hard. Raw GP data, 1 row per event, but you want to turn it into something that's much more like 1 row per person. So, for example, you want to know, is this a child with asthma as an active problem in 2024? Well, you can't just go, okay, I'm going to write a list of asthma diagnostic codes and then search for those, because there are loads of children who've had asthma diagnostic codes entered, and then they got a blue and brown inhaler once 4 years ago, and then they never got a blue and brown inhaler ever again. That is not a child with asthma. So identifying a child with asthma requires that you do something like, every child in the world, we're going to say yes, they are a 1 for has asthma in 2024 if they've ever had a diagnostic code for asthma ever in the past, and they've got more than, let's say, 3 prescriptions for asthma treatments within this 12-month window. So once you start writing those rules, that's suddenly really hard work. The code is usually tethered to 1 database. It's very rarely shared, and also everybody does that job completely differently. So we wanted, but we also needed to standardize electronic health records management. So we built some point and click tools for things like making code lists, which you can use regardless of whether you use OpenSAFELY, and lots of people in the industry use them as well. But we also made a dynamic set of standardized tools for preparing things. So this is from the documentation: find the mean observed value of a list of clinical events matching some criteria. What's the code of the first or last clinical event within this list of events within this date range? And the idea with Urkel is that it makes EHR code readable, reusable, portable, and standardized. So this is a quick example of what it looks like. So you're making a variable called recent asthma treatment count. So how many treatments for asthma? And then you say, okay, I'm interested in prescriptions, where the prescriptions DM and D code, drug medicines and devices code, is in this code list you've already made called asthma medications, which you can find instantly and immediately because your repo is synced to those things. And you say where the date is after this, back to 1 year before that, and I want you to return a count for that patient. And so that's my variable called recent asthma treatment count. And then the nice thing about this is it's not Jane Austen, but it is readable, and it's readable by clinicians. And that means clinicians can check that your logic matches their expectations. So you're not doing what the NHS does with QOF, where it says, okay, in this email, okay, seriously though, is the definition for this diabetes thing in QOF. So we've attached some Excel spreadsheets. So we're going to say that somebody's eligible to be in the numerator if they've got all of the codes in sheet 1, but none of the codes in sheet 2, and they describe in prose what they want you to do for data management. It's absolute madness, right? Here, you express it in code, and it is to an extent human readable. But it's also reusable, so you can reuse it, and you can reuse it in other contexts. So that means it's composable. It's like electronic health record data preparation Lego, right? So you can say, has asthma is a 1 if you've both got an asthma diagnosis and your recent asthma treatment count is greater than 3. And then I'm going to say, well, I'm going to use that in my variables library, and then I'm going to change it. So I want to change the years or the date range. So it's composable, it's portable, it runs in multiple different data centers. And also, critically, it is composable. It's, you can stick it together in different ways. Right! I've stopped talking. Hello.
Thanks very much. The deaths with tears wiped off quote is never known who originally said it. It's often attributed to people, but we don't know. Probably Irving Sellicott was the guy who demonstrated that asbestos caused cancer. Claimed he'd said it, but it turned out he'd made up his medical degree. So, believe it or not.
Butterfinger.
Okay. So, questions, Richard.
Hi, thanks, Ben. That was really good. I just wanted to ask you that trial.
Sorry.
I'm Richard Martin.
Oh.
I'm a professor of clinical epidemiology. And I wanted to ask you about the trial that you incorporated from Bristol.
Yeah.
So with that, are you intending to do more of that? Because obviously that would make massive trials very, very cost efficient in terms of collecting baseline and outcome data, etc.
Yes and no. I mean, data infrastructure is a really challenging space to work in politically as much as technically. NIHR has run every 2 years a call for few million quid to do a super efficient way of doing randomised trials. I'm not sure that I see much forward plot movement on that. I've been a part of consortiums that have applied unsuccessfully. Clinical trials is a really big, expensive space with a lot of existing players, and I think our appetite for going into bat in that is low. What we have done is we've actually delivered the first ever randomised trial that is at anything like that scale, where all we did was ingest the trial randomisation schedule, match it onto the EHR data, and let the researchers analyse the data inside the TRE. We did it partly because when I came out in 2022, almost as testament to what a sort of challenging space this is, there were lots of senior trialists saying, well, this is all very well, but for example, you couldn't possibly do trial follow-up in a TRE. And I tried to sort of engage with people and understand what they meant when they said that, and I couldn't get an argument of why you couldn't do it. And we just thought, well, the best way to show that you can do it is just to get on with it and do it. And so we did do it. To run, however, a full clinical trial service, super efficient, low cost, randomised trial unit in primary care, I think you need more than just trial follow-up after you ingest a trial randomisation schedule. So, for example, if you're doing a CTIMP, then lots of people in the MHRA get tearful about all kinds of regulatory things, and they want things that nobody in the modern world can even really give them. Like they want to say, I want the case report form, and I want that to be verified as being the same as the underlying record. And if you say they are both the same thing in the same database, they are literally the same thing. I had this argument with Chad Van Staal when we did a trial in CPRD in 2008. MHRA said, we need to verify, if you're following up in CPRD, we need to verify that the trial report form is the same as the patient record. And we said, well, they're both coming from the same place. They're both coming from CPRD. In the end, Chad said, would you like me to do a SQL query to produce the electronic health record? And then I can run the same SQL query immediately afterwards to produce what we can call the trial record. And you can verify that they're both the same. And the MHRA said, that would be great, thank you. Right? So there's lots and lots of regulatory stuff. The only way to do it would be to have a collaboration at the scale of, 2 teams, probably 3 million quid for a couple of years, clinical trials unit with experience of primary care, randomised trials, and OpenSAFELY TRE team and EHR team. And then you could do it. But it's not a 5-minute job.
Lucy, it was also cluster randomised.
It was cluster randomised, but if it had been individually randomised, it would have been exactly the same thing. I mean, it's almost easier to ingest person level data rather than practice level data, weirdly, because of some aspects of how the systems run.
So Peter, then Guy.
Peter Openshaw.
Oh,
Hi. Can you say more about where you're going beyond COVID? I mean, I wasn't sure whether you were saying you wouldn't talk about that or when.
oh right, yeah.
You're on the Today programme talking about it.
I wouldn't talk about new technical tools, but I would talk about that. So, the paperwork is now at a kind of very advanced stage. We're expecting it to be issued in the next, hopefully, couple of weeks. And that's to expand to non-COVID clinical questions. And we're going to do it cautiously and in collaboration with the professions and profession advisory group. It looks like get a say on the projects, and AGD will be closely involved, and we will edge out. If you've got good studies that are non-COVID, the time is now. team@opensafely.org is our email address. And we're particularly interested in things that will come through quickly. So, 18 months of hand-wringing about what is exactly the right model and what do we think about the answers for a particular epi study is great. But what we'd really like actually is probably good old-fashioned descriptive stats for health services research that can start having impact quickly, because that will please and excite NHS England and Department of Health.
Guy?
You Guy probably a Pro-Vice Chancellor for Research and Innovation here. It might relate more to kind of where you're going, but it's a really interesting talk. I wondered what possibilities there are of kind of interfacing your database with other complex data sets, for instance, the Met Office's environmental data sets, which might then be able to overlay on some of the events that we're seeing and open up some interesting avenues.
So a really interesting and really timely question. So as I mentioned, we were previously running a bring your own data service where people just give us a data set and we ingest it and link it on. That was a terrible way to do that job because each individual data set, people would send us the entirety of their thing and then they'd want to do data preparation on our machines and all of that. So we have devised and written up actually in a paper that's about the National Data Library, who we're hoping to work with in the next few months. A paper on how to design the National Data Library, and we've laid out a model of how you could do data preparation at source, pre-prepare the data locally, and then the minimum amount of data moves just in time for linkage per project into whatever data analysis environment makes the most sense, rather than putting all of the data in one giant machine, which is bad for privacy, bad for efficiency, bad for transparency, bad for all kinds of things. So our first proposed project on that in our National Data Library paper, and that we've been discussing with the NDL team, is about precisely what you asked about. And we started with that because although we've got contractual arrangements with things like Twins UK for person level data for some cohorts where a derived subset of their raw data comes into an OpenSAFELY environment in Venus or TPP or wherever else, it's probably quicker and easier and also bigger research footprint to start with a non-personal data set elsewhere, in particular because the next thing that we want to do is not something that's big in terms of research outputs. We want to do something that's big in terms of proving the value and also learning about the challenges of that way of working in that very federated way. And you only do that by actually living it and breathing it and doing it. So that's precisely what we've proposed. And Antonio Gasparini at London School is in the list of people who'd like to work on that, as is the chap who left London School and went to Imperial, Paul Elliott. And if there's anybody here that's interested in that as well, that would be really great. And you could start very quickly as well, potentially, because you could do rainy days and COVID.
Yeah. I think so.
Thanks, Bennett. So, like a follow-on to the opening up to broader than COVID questions. So one of the really positive things in the pandemic was that ability for policymakers to ask a question and to get a quick answer. So what are the plans for sort of maintaining that close relationship and being cautious? So some questions would be clearly in the public good and others could be quite heavily politicized, and have you teased that side of things out as well?
So as far as possible, I try to stay a long way away from all of that, honestly. But our expertise as a team is in the technical aspects of how do you build platforms that manage privacy and transparency to earn trust, and efficiency and quality for rapid preparation and analysis of data. I've deliberately constructed the whole of OpenSAFELY from the outset in such a way that NHS England make decisions about the priorities of the projects that run through it. We advise them on feasibility, because lots of people come to you because they've heard about GP data on the Today programme and they propose a project that actually can't be done in GP data. But aside from that, the question, how do you get the NHS to bluefully prioritise its own analytic questions, is a really big and difficult one. I wrote about it a lot in my review in 2022. My recommendations on that, I would say, are the only ones that weren't picked up by government. So I said, make contracts so that code is open by default and use TREs instead of dissemination. They bought that. When it comes to data analysis in the NHS, I think, honestly, we're still all at sea. And we're all at sea because we don't have an NHS analyst service in the same way that we have a government economic service, government statistical service, government operational research service with standard job descriptions at each level and continuing professional development to get people along, and two parallel sets of line management in GES, GES, and all of government analytic functions. You've got your line manager in Department for Education who cares about the stuff you're doing about this education policy, and you've got your parallel line manager for your profession in your community of practice in the government analytic function. In the NHS, you've just got kind of anarchy, and as always in anarchy, you've got some good people and some bad people.
I think we've got to stop because we're going to move out of the room. I can go. Here's the email from Ben Longstaff, PA, saying he will be there on time. Never. Thanks again.